Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in just about any college mathematics course, please consider subscribing, checking out our playlists, watching videos, liking, commenting, sharing those videos. Those are all really helpful interactions because it does help us to grow, reach a bigger audience, and therefore we would greatly appreciate it. So I can get into the current video. I want to take a look at something called Pythagorean conjugates and how we can use them in integration. Now here's a list of Pythagorean conjugates, and I wrote all, I'm not going to use all of those, I'm going to use one of them to kind of illustrate the idea, but go ahead and pause the video and write those down in your notebook just so you kind of have them for reference. But here's the idea. If I was to take 1 minus sign and I multiply it by 1 plus sign, or if I multiply those together, then I'm going to simplify using one of the Pythagorean identities. That's going to equal cosine squared. Therefore, if I see an expression in say a denominator in an integral of a 1 minus sign, then I could multiply the top and the bottom by 1 plus sign, and then that denominator, which has a 1 minus sign, is going to convert to a cosine squared, and that might end up giving me a simpler integral to do. So what I'm going to do is I'm going to take a look at the following integral. Let's compute the integral from, say, 0 to, let's say, pi over, let's do pi over 4, and then I'm going to do 1 over cosecant minus 1 dx. Okay. Now, any other integration technique that you have learned in your Calc 2 course, I'm assuming if you're watching this, you're probably in Calc 2 or have taken Calc 2 at least. Nothing else is going to apply here. I can't do any sort of integration by parts or use substitution. None of those things are really going to be effective. Even if I turned cosecant into, say, 1 over sine, then I multiply top and bottom by sine, it's going to give me, sine over sine minus, or 1 minus sine. And then I'm still going to have to try to figure out, how to integrate that. And it turns out in that case, I could just use this Pythagorean conjugate. But let's go ahead and compute that again using a Pythagorean conjugate. Since I've got cosecant minus 1, that tells me that I'm going to use this pair, of course, right here. And here's how this works. I'm going to multiply top and bottom by cosecant plus 1. So I get cosecant of x plus 1 over cosecant minus 1 times cosecant plus 1 dx. Okay? And of course there's nothing to do on the top, so we'll go ahead and leave that alone for the moment. So pi over 4, 0, got cosecant plus 1. And then of course when I multiply this together, I'm going to get cosecant squared. And then notice the middle terms are going to be positive cosecant minus cosecant. So in other words, those two intermediate terms, the O and the I right of FOIL, are going to cancel because they're additive inverses. And then of course negative 1 times 1 is going to give me negative 1, and then dx. Okay. Now, I didn't really have space to write up all the different Pythagorean identities up on the board, but cosecant squared minus 1, what does that equal to, right? So cosecant squared minus 1 is the cotangent squared, so that gives me 0 to pi over 4 of cosecant of x plus 1 over cotangent squared x dx. Alright, so what I've done is I converted this original integral to this one down here using a Pythagorean conjugate. Now this one is going to be much easier to compute because cosecant and cotangent, I can turn both of those into sines and cosines. So let me go ahead and clean this up, and then I'll continue on the other side of the board. Okay, here we go. Well, first and foremost, what I'm going to do before I turn this into sines and cosines, I'm going to separate the integrand. 0 to pi over 4 of cosecant over cotangent squared plus 1 over cotangent squared. Now, I'm going to work with both of those terms differently. This first one I'm going to again write in terms of sines and cosines. Cosecant, of course, is 1 over sine. This gives me 0 to pi over 4 of 1 over sine over, so cotangent would be cosine over sine, and then I've got that squared. Now 1 over cotangent is tangent squared, or 1 over cotangent squared is tan squared, so this is plus tan squared x dx, okay? And then, let's see if I flip and multiply, this first term is going to give me, so 1 over sine, and I'm going to flip this, giving me sine squared over cosine squared. And so then we'll work that here in a moment. And then notice for the tangent squared, well, we don't have an immediate, unless you have these memorized, right? One way to do this, if you don't have an antiderivative memorized for the tan squared, is I could use a Pythagorean identity, and I could write tan squared as secant squared minus 1. And both of those have antiderivatives that should be pretty familiar to you. So that's how we are going to work with the tangent squared. And then for this term here, notice I can cancel a factor of sine. That's going to give me an integral from 0 to pi over 4 of sine x over cosine squared. And I'm going to integrate this term separately from this one, so let's separate the integral. Okay. All right, I'm going to clean up that side, and then we will continue. Okay, let's call this one integral 1, and we'll call this one integral 2. So we'll evaluate those differently. Let's start with integral 1. So I1 is equal to. So in other words, well, before I do that, notice for integral I1, so let me clean that up first, we can use a u substitution. So for integral I1, I'm going to say u is cosine of x. So then du would be negative sine of x. Okay, and we'll convert back to the original variable in the end. So let's go ahead and just do that integration as a definite integral, and then we'll bring back the original variable, use the original limits of integration. So I1, the first integral, would be, well, I don't have a negative here, so to compensate that, I have to put a negative and then cancel it, giving me negative integral of sine x dx would be du, so that's 1 over u squared du. In other words, negative integral u to the negative 2 du, which is negative u to the negative 1 over negative 1, which is 1 over u, right? And again, if I convert this back to the original variable, that means I would have 1 over the cosine, and we are evaluating x from 0 to pi over 4. Plug in pi over 4, I get 1 over cosine of pi over 4 minus 1 over cosine of 0. And cosine of pi over 4 is root 2 over 2. I get 1 over root 2 over 2. Cosine of 0 is 1, so this is minus 1. And then if I simplify 1 over root 2 over 2, in other words, flip and multiply, I get 2 over root 2. And of course, 2 over root 2 is root 2. That gives me root 2 minus 1 for the first integral. All right, now let's go ahead and compute the second integral. For integral 2, This was integral from 0 to pi over 4 of secant squared x minus 1 dx. Antiderivative, of course, of secant squared would be tangent. Antiderivative of negative 1 would be negative x. Evaluate from 0 to pi over 4. Plug in pi over 4, I get tangent of pi over 4 minus pi over 4. Minus, of course, if I plug in 0, I get 0 minus 0, or 0. So therefore, I get tangent of pi over 4 minus pi over 4. And then, of course, tangent of pi over 4 is root 2 over 2. That gives me root 2 over 2. Root 2 over 2 over root 2 over 2, which is 1, minus pi over 4. Okay, now if I go ahead and the original integral would be I1 plus I2, which would be root 2 minus 1 plus 1 minus pi over 4. The 1's cancel, giving me root 2 minus pi over 4. Okay, as my final answer. So once again, if you see any of those expressions within the pairs of Pythagorean conjugates in a denominator, go ahead and try to multiply it out just like I did and see if that works for you. But anyway, thank you for watching. Please consider subscribing.